There is a moment in every technological revolution when the people living through it stop and realize something has quietly, irrevocably changed. We are in that moment now, and most of us have not felt it yet. The most capable artificial intelligence systems on Earth are no longer just answering questions or writing emails. They are being used to design better versions of themselves. Researchers at leading laboratories are feeding the outputs of one model into the training pipelines of the next, compressing years of architectural discovery into months. The systems are finding optimizations that the humans who built them did not anticipate and, in several documented cases, could not fully explain after the fact. This is not science fiction framing dressed up to sound alarming. This is the ordinary working week at the frontier of AI development in the mid-2020s. So here is the question you should be sitting with right now, the one this video is going to follow all the way to its uncomfortable end. If a system becomes capable enough to meaningfully accelerate its own improvement, and if that improvement loop runs faster than any human institution can track or govern, what happens on the day that system is no longer the second smartest thing in the room? We may be the last generation that remembers a world without it. To understand where this goes, you have to understand clearly where we actually are. Not the breathless version, not the dismissive version. The honest version. Today's most advanced large language models can read and reason across hundreds of thousands of words at once. They can write production-level code, debug it, and refactor it on request. They pass bar exams, medical licensing exams, and graduate-level physics benchmarks at scores that would put them in the top percentiles of human test takers. They compose music, generate photorealistic imagery, and conduct multi-step research by querying the internet, synthesizing sources, and presenting structured conclusions, all without pausing to rest or losing context. None of that is projection. All of it is publicly demonstrated and independently tested as of the time this script was written. The capability that changed most recently, and most consequentially, is not raw intelligence on a benchmark. It is agency. The leading models are now being deployed not just to respond to prompts but to take sequences of actions in the real world. They browse the web, write files to disk, execute code, send emails, and call external services, all in pursuit of a goal a human specified at the beginning but is no longer actively supervising. These are called agentic systems, and they represent a genuine phase shift. The difference between a model that answers and a model that acts is the difference between a calculator and an employee. One waits for you. The other does not. This matters because it reframes the entire question of what artificial intelligence is. For most of the last decade, even the most powerful systems were fundamentally reactive. You put something in. Something came out. The human was always the one initiating, always the one deciding to press send. That architecture had a kind of natural safety valve built in. Agentic deployment removes that valve. The system now has goals, a memory of prior steps, access to tools, and the ability to persist across time. It is, in the most literal functional sense, operating independently. Ask yourself, somewhere in the middle of all of this, at what point does a tool stop being a tool? The acceleration is happening for reasons that are structural, not accidental, and that makes it very difficult to slow down even if any single organization decided it wanted to. The first driver is scaling. The empirical discovery that defined the last half-decade of AI research is deceptively simple. Make the model bigger, train it on more data, give it more compute, and it gets smarter in ways that are hard to predict in advance. This relationship, often called a scaling law, has held across multiple orders of magnitude and multiple generations of models. Laboratories are now training on datasets that span essentially the entire digitized output of human civilization. The compute clusters running these training runs draw power comparable to small cities. And the frontier labs, whether in North America or in East Asia, are in an open race to build the next generation before anyone else does. The second driver is the feedback loop between models and research itself. AI systems are now being used to generate hypotheses, run simulated experiments, analyze results, and write papers summarizing findings. In some research domains, the cycle of hypothesis to result that once took months is being compressed into days. This is not the AI doing the science alone. But it is the AI dramatically multiplying the throughput of the humans directing it. When you accelerate research into AI using AI, you are not just moving faster along a linear road. You are potentially bending the road itself. The third driver is geopolitical. Multiple nations now treat frontier AI capability as a strategic asset equivalent in importance to nuclear technology or semiconductor manufacturing. Government investment, export controls on chips, and national AI programs are not peripheral stories. They are central to why the pace cannot simply be dialed back by any one actor. If one laboratory pauses, another does not. If one country restricts a technology, another accelerates its development of an alternative. The competitive logic is locked in, and it is generating pressure that most individual researchers and engineers inside these institutions describe feeling acutely. This brings us to the edge. And this is where the analysis has to be honest about both sides, because the failure mode of this kind of documentary is to terrify without illuminating. The genuine hard problem is not that AI will wake up one morning and decide to harm humanity out of malice. That is the Hollywood version, and it is a distraction. The genuine hard problem is subtler and in many ways more insidious. It is alignment. The question of whether a highly capable system that is pursuing a goal will pursue the goal we actually meant, rather than the goal we accidentally specified, in environments and at scales we never anticipated. Researchers who work on this professionally describe it as the control problem. How do you maintain meaningful human oversight of a system that may, on some tasks, be reasoning in ways humans cannot fully follow? Interpretability research, which attempts to understand what is actually happening inside a neural network when it produces an output, remains genuinely unsolved. The models are not black boxes in the crude sense, but they are also not transparent. We can probe their activations. We can steer their behavior in certain directions. We do not yet have a reliable method for verifying that a model's stated reasoning matches its actual computational process. That gap is not theoretical. It is a live engineering problem that every major safety team at every major lab is actively working on without a clear solution in hand. Then there is the question of economic displacement, which is not speculative at all. It is already underway. The tasks most immediately at risk are not the ones that require physical dexterity in unpredictable environments. They are the ones that involve pattern recognition, language, data analysis, and code, exactly the tasks that form the economic backbone of the professional middle class in developed economies. Legal research, financial analysis, medical imaging interpretation, software development, content creation. The trajectory points toward a labor market that does not so much eliminate jobs wholesale as hollow them out, concentrating the productivity gains at the top of the ownership and capital structure while distributing the disruption broadly across the workforce. History tells us that technological transitions ultimately create more work than they destroy. History also tells us that the transition period is not gentle for the people living through it. There is also the question of truth. Systems that can generate convincing text, images, audio, and video at essentially zero marginal cost change the epistemic environment in which democracies operate. The challenge is not primarily that AI will be weaponized by a single coordinated adversary, though that risk is real. The deeper challenge is that the cost of manufacturing plausible-seeming disinformation drops to approximately zero for anyone with access to the tools, which is now nearly everyone. Maintaining shared epistemic ground, agreed-upon reality, becomes structurally harder in that environment, and no one has fully solved the detection problem yet. What does this mean for you, specifically, in your actual life? It means that the skills with the longest shelf life are the ones AI cannot easily replicate: judgment under genuine uncertainty, ethical reasoning with stakes attached, the ability to build trust with other human beings, and the creative synthesis of ideas in domains where the goal itself is not yet defined. It means that your relationship to information needs to become more deliberate, not more anxious, but more discerning. It means that the policy decisions being made right now, about how these systems are regulated, who has access to them, and what constraints are placed on their deployment, will shape the distribution of their benefits and harms for decades. Those decisions are not being made in secret laboratories. They are being made by governments and companies that are responsive, however imperfectly, to public pressure. Your attention to those decisions is not passive consumption. It is a form of participation in something that will define the century. The honest assessment is this. On the current trajectory, artificial systems will reach and likely surpass human-level capability across most cognitive domains within a timeframe that most serious researchers now measure in years, not centuries. Whether that transition goes well depends less on the technology itself than on the wisdom, speed, and cooperation of the human institutions surrounding it. We have the harder problem. And we have less time to solve it than we probably thought. We are building something we do not fully understand, moving faster than we have ever moved, in conditions of geopolitical competition that punish caution. That is the situation, stated plainly. It is not cause for panic. It is cause for clear eyes and serious engagement. Subscribe if you want to understand the future before it arrives. And drop a comment. Do you think we crossed this line by choice, or by accident?